Hello and welcome to where we are going to be working on everybody's favorite topic for sure, word problems and problem solving. So before we get started, we'd like you to watch a little video about a couple people working on a problem. If you haven't seen it yet, go ahead and pause the video now and use the link right above this video to watch that video on YouTube to see how they take care of a little problem solving. Okay, great. By now you've seen the video. I think it's quite funny. They do some pretty good stuff here, and they just cannot get the math right. 13 times 7 is 28. That's pretty funny. So, when doing a problem-solving situation like this, there's a couple things you're always going to want to do. First of all, you're going to want to read the problem twice. Most people get a problem wrong because they only read it once and they just miss something about the problem. You're always going to want to read it twice. Second of all, you're going to want to look at a picture if they provide one, or draw a picture. Pictures are very powerful and can really help you solve problems. Step number 3 is to translate the problem to an equation. Then to solve that equation is step number 4. And lastly, you want to check and state your answer. This is where they failed in this problem. They never really checked the answer. Well, I guess they checked it 3 different ways, but they checked it wrong all 3 ways. So it's really critical to follow these 5 steps when creating a word problem. There are 6 specific types of problems that we will be discussing in this video, which you will want to make sure you know how to do each of the specific 6 types of problems. Let's get started with the first one. The first type of word problem we want to talk about is a cutting problem. Let's say that we had a string. You'll have to bear with me here. I'm not a very good drawer, and it's even harder on the computer. But let's say that this string is, I don't know, 30 feet long. 30 feet long. And our goal is to cut this string somewhere along the string with some scissors. And when we cut that, we want one side to be 8 feet longer than the other. So here's one side. And we want this side to be 8 feet longer. So we have one side and then another side that's 8 feet longer than the other. So when setting up this problem, again, it's always good to read it twice and then also to look or draw a picture. So I've drawn the picture here. The next thing we want to do is set up an equation. I know that this small side is going to be x. And because the other side, the longer side, needs to be 8 feet longer, we could represent that as 8 plus x. Okay, good. Now we want to work this into an equation so that we can solve it. So I would know that x, the small side, plus the long side, that would equal the total length of the string, which is 30 feet. We then can solve this equation using the law of opposition, of which we've already talked about in this chapter. We know that x plus x is 2x. We then would subtract 8 to both sides because that's the opposite of plus 8. And lastly, we would divide by 2. So we find out that x equals 11, which means the small side is 11 feet, and the long side would be 11 plus 8 feet, which would be 19 feet. And notice that if you took both of these and added them together, it would add up to 30 feet. So that's the first type of problem, a cutting problem. Okay, so it's your turn. How about you try a cutting problem? Here's the problem. A board is to be cut so that the larger piece is 12 feet longer than the smaller piece. If the board is 22 feet long, how long are the 2 pieces? Go ahead and pause the video and give this a shot, and when you're ready to check your answer and see how you did, resume the video. Okay, so how'd you do? On this one here, you would want to make sure, again, to read the problem twice. I would have drawn a picture. I would have drawn a board. Now, I'm not much of a drawer, like I said, but there we go. This is 22 feet long, and somewhere in here we are going to take a saw with a handle and cut this board so that we're going to have a small piece, which I'm going to call x, and then a bigger piece, which is going to be 12 feet longer than the smaller piece. Okay, sweet. So now we can write this equation. We can say that x plus 12 equals 22 feet. I combine the like terms. 2x plus 12 equals 22. We minus the 12. We get 2x equals 10. So x equals 5 feet. Meaning that the smaller piece is 5. And that would mean that the longer piece is 5 plus 12, which is 17 feet. That's the size of those two boards. Okay, here's another word problem we'd like you to try. Go ahead and read the problem. Actually, I'll read it. It says, the Wright family just finished a 700-mile road trip. On the first day, they traveled to a hotel. The next day, they traveled 30 more miles, then 2 times the amount they traveled on the first day. How much did they travel each day? Go ahead and pause the video and draw a picture. Follow the steps here. Set up an equation. Solve the equation and check your answer. And let's see how you do. Push the play button when you're ready to resume. Okay, let's check it out here. So we know their total trip was 700 miles. Now, I don't know how you drew a picture here, but I'm just going to draw a really long road. And I'm going to call this 700 miles. That's not a very good road, but pretend it's a really good road. They went 700 miles. Now, somewhere along here, they stopped at a hotel. Hotel. Okay, that's kind of how the problem gets cut. Remember, we're talking about cutting problems. So they traveled a certain amount of day. They stopped at the hotel. The next day, they then traveled, hopefully on the right side of the road, and they finished up. Now, these 2 days put together will add up to 700 miles. So we need to define a variable. Let's define the variable x as how much they traveled the first day. So the first day, they traveled x miles up to the hotel. They then told us that on the next day, they traveled 30 more miles, 30 plus, than 2 times what they traveled the first day. So again, x represents the first day travel. The second day travel would be represented by 30 plus 2x. We can then set up this equation by adding these together. It would be x plus 30 plus 2x equals 700. We would combine the like terms. We get 3x plus 30 equals 700. We would minus the 30. We get 3x equals 670. We then would divide by 3. 670 divided by 3 is about 233.3 miles. So on the first day, they traveled 233 miles. 233.3 miles. And on the second day, we would have to figure out that. We would have to plug this value in to figure out what they traveled on the second day. 30 plus 2 times 223 miles is 476.6 miles. Sorry, this should say 223 miles. Okay, great. How'd you do? Hopefully you did pretty well. Let's go ahead and move on to the next type of problem. Okay, the next type of word problem that we're going to deal with will be one which is a rectangular word problem. You'll be given some information about, maybe this is a picture. Let's do my family picture here. Oh yeah, that's cute. There's me, my wife, and 3 little kids. They get smaller. Okay, a little baby. Yeah, okay, pretty good. So we've got a picture here, and we know that the perimeter of this picture needs to be 120 inches. They tell us that, and they also tell us that the length is going to be 3 times the width. Now we know that this is the length, and that this is the width. If the length is 3 times the width, we could actually write the length as 3 width. Okay, so we know that perimeter is the distance all the way around. So this would be W, this would be 3W, this would also be W, this would also be 3W. And so we could set up this equation by adding all these W's. We'd have 3W, 6W, 7, 8W's. And it would be 8W equals 120 inches. We then would divide by 8, We could use a calculator there if we needed to. 120 divided by 8 is 15. So we know that the width is 15 inches for this picture. If we want to find the length, we would just have to plug 15 back into our length equation, which was 3 times the width, which would be 45 inches. So for this picture, to have a perimeter of 120 inches, the dimensions would be 15 for the width and 45 inches for the length. That's how we do a perimeter problem when it's a word problem. Okay, so now it's your turn to try one of these rectangular perimeter problems. Here the problem says a rectangular garden is to be 4 times longer than its width. If the garden has a perimeter of 415 feet, what are the dimensions of the garden? Go ahead and pause your video, give this a shot, make sure to draw a picture. It really helps to draw a picture. And press the play button when you're ready to resume to see how you did. Okay, great. So let's go ahead and draw a rectangle here. Whoa, that was not a rectangle. Boy, that's a bad rectangle, but you'll get the idea. So we've got a garden here. You maybe drew some flowers. That's kind of cool. Maybe you drew some bushes. In my garden, there's always lots of weeds. And so we could label these things. We know that this is the width and this is the length. Now they tell us that it needs to be 4 times longer than its width. So I know that the length is going to be 4 times w. Okay, 4 times w. So that means over here we have 4w, over here we have 4w. Well, this would be w, and this would be 4w. If we added these all up, we get 10w for our perimeter, and we want that to equal 415 feet. When we divide that by 10, we find out that the width is 41.5 feet. That's how wide the garden is. To find the length, we would need to plug that back in to the length equation. In other words, it's just 4 times that. 4 times 41.5. You should have found out that the length was 166 feet. How'd you do? Okay, great. Let's take a look at the next type of problem. The next type of problem we need to talk about are ones that involve consecutive numbers. A consecutive number is any number that follows each other. So 3 and 4, those are consecutive. Or 8 and 9, those are consecutive. Or 23 and 24. Numbers that are right next to each other are consecutive numbers. And when dealing with consecutive numbers in equations, we usually write them as x being the first number, and the next number being x plus 1. That would make sense. If our first number was 3, then the next consecutive number will be just 1 more than that. Or if it were 23 as x, well, the next number would be just 1 more than that original number. So, let's take a look at this problem here. It says 2 consecutive numbers have a sum of 131. Find the numbers. Okay, so sum means add. So my consecutive numbers, the first number would be x, and the next number would be x plus 1. Okay, and because it's a sum, we use addition. So again, this is the first number, this is the second number, and we know they add up to 131. Well, now we can just combine like terms and solve. X plus x is 2x, plus 1 equals 131. We subtract the 1, I get 2x equals 130. Sorry, this should have been still a 1 here. I was getting ahead of myself. And then I divide by 2. 130 divided by 2 comes out to be 65. So my first number is 65, and the consecutive number would be 1 more than that, which would be 66. Those are my 2 numbers, and if you tested it out, 65 and 66, 65 plus 66, yes, comes out to be 131. Okay, great. So you got the idea of consecutive numbers. Consecutive numbers are written as x, x plus 1, x plus 2, x plus 3, and so on. So what about this one here? If we had 3 consecutive integers that add up to 72, could we find those numbers? Well, of course. The first number is just x, the next one is x plus 1, and the next one after that is x plus 2. Again, we're always using that x as a base number. These would add up to 72. All we'd have to do is combine the like terms, 3x plus 3 equals 72. We minus the 3. We get 69. So x equals 23. So that's the first number. 23 is the first number. The next consecutive integer after that would be 24. And the next one after that is 25. So these are our three consecutive integers. So let's look at these next problems here, where we're dealing with odd integers. It says 3 consecutive odd integers add up to 129. Find those odd integers. So again, odd integers will be added on by 2. So if this was 7, to get to my next odd integer, I add 2. To get to my next odd integer after that, I'd add 2 more. And so this will be the setup here. We will use x plus 2 plus x plus 4 equals 129. We'll then combine the like terms. We get 3x plus 6 equals 129. We then can subtract 6 to both sides to get 3x equals 123. We then divide 123 by 3 to find out that our first odd integer is 41, which means the next odd integer is 43, and the next odd integer after that is 45. Okay, it's time for you to give these a try. Here's 2 problems for you. Take out your video notebook and give these a try. The first one is 3 consecutive integers. We know they add up to 111. Can you find those 3 integers? The next problem is to take, we're given 2 consecutive even integers, and we know they add up to 114. What are those 2 even integers? Pause your video now, work on those problems, and then push the play button when you're ready to check it out. Okay, great! Let's see how you did. You should have worked these out on your notebook. Again, we have 3 consecutive integers, so that would be x would be my first integer. The next one would be x plus 1, and the next one after that would be x plus 2, and we'd want those to equal 111. So I have how many x's here? 1, 2, 3 x's plus 3 equals 111. We then can subtract 3 to both sides to get 108. Lastly, we divide that by 3. 108 divided by 3 is 36. So our first integer is 36. The next one is 37. The next one is 38. That would be our answer for the 3 consecutive integers. And notice we used x, x plus 1, x plus 2 to denote those integers. On the next one, we have a slightly different setup because they're even integers. So the first integer is x, and the next one's going to be x plus 2 because they're even integers. To get to the next even integer, you got to add 2. That adds up to 114. We combine the like terms. We get 2x plus 2 equals 114. Subtract the 2 over. We get 112. 112 divided by 2 is 56. So the first even integer is 56. The next even integer would be 58. That's how you do problems with consecutive integers or consecutive even and odd integers. Nice work. The next type of word problem that we're going to have to deal with are the triangle problems. Now, when dealing with the triangle problem, it's pretty simple. It's always going to be laid out for you, but the one thing you got to remember is how many degrees there are in the angles of a triangle. Does anybody remember? This is like the key of the lesson. You need to remember that there are always 180 degrees in the angles of the triangle. In other words, if we took this angle, that angle, and this angle, and added them together, it would always add up to 180 degrees. So when setting up the problem, all you have to do is write out the angles. 2x plus 1 plus x plus 4. So I wrote this angle. I'm going to write this angle. Now I'm going to write this last one, 3x minus 5. And we know those angles will always add up to 180 degrees. We then can combine our like terms like normal. 2x plus x plus 3x. Let's see, 2x, 3x. That's 6x. Plus, this is 1 and 4 minus 5 is, oh, that just comes out to be 0, equals 180. We then divide both sides by 6, and we get x equals 30. So knowing that x equals 30, we could actually go back and plug those back into each of the individual angles to find out what the angles would come out to be. So if x equals 30, and we come back to this one right here, well, we know that that means this angle is 34 degrees. And if we came to this one here, well, we would do 30 times 3 minus 5, and we find out that this one here is 85 degrees. And if we took 30 and plugged it back in here, we'd find out that this is 61 degrees. And so our angles, our answer would be, well, 61 degrees, 34 degrees, and 85 degrees. So again, moral of the story here is take all the angles, add them up, and make it equal to 180. And then you can solve for the problem. Okay, so it's time for you to try one here. I've written out a new triangle. This angle here is 7x minus 30. This one is x plus 50. And this one is 2x plus 10. What we'd like you to do is go in and solve this problem. Find the value of x, and then find the value of each angle. Go ahead and pause the video and give it a try. Push the play button when you're ready to resume. Okay, we know that all angles of a triangle will always add up to 180. So I'm just going to simply write out all the angles here and set it equal to 180. Then I'm going to combine the like terms. When I do that, I get 10x. Here's a minus, oh, this is 50, minus 30, and here we have plus 60, so we got plus 30 equals 180. We minus the 30 to both sides to get 150. We then divide by 10 to get 15. So we find out that x actually equals 15. You can then go back in and plug these in to each angle to find the actual value of them. Oh, this is going to get colorful with this pink here. So I would go 7 times 15 minus 30 to find out that this angle is 75 degrees. I then could take the 15 here and find out that I get 15 times 2, which is 30, plus 10, is 40 degrees. And last of all, we can plug 15 here to find out that this angle is 65 degrees. And that's how you do a triangle problem. How'd you do? If you didn't catch it, feel free to watch that part of the video over again. We've got one more type of word problem that we need to talk about, and then we'll turn you loose. So the last type of word problem is an averages word problem. How do you find an average? Now, you may remember this from back in the day, but if you wanted to find an average of a bunch of numbers like 5, 6, 15, and 20, well, to find the average, you just add all the values up. So average equals, you add all the values up, and then you divide by the total number there are. So we had 1, 2, 3, 4 values. That's how you find the average. So in an average word problem, you're going to have to find something else. You'll actually have to find a missing value. For example, let's say on a test you scored an 80%. On the next test you came in, did really well, scored a 95%. And you have one last test score, but you don't know what it is because you haven't taken it yet. So we'll call it X. And you want to get a 90% in this class. You want your average to be a 90%. So we know that the average you want is a 90%. So the question is, what do you got to do? What do you got to get on that third test to get this average? So we'll use the same formula that we just wrote up. So to find an average, remember we said to find an average, whoa, I spelled that wrong. An average, you're gonna have that equal the number, the values you got, so A plus B plus C plus however many you have, divided by the total number. So in this problem, they gave us the average. We want the average to be 90. They then gave us the three values, which are 80 plus 95 plus X. We don't know the last one. Divided by the total number, well, there's three values. So this is how you set an average problem up, and we would solve from here. To solve, you simply would undo the division. Notice we have a divide by 3. To undo divide by 3, we would multiply both sides by 3. When doing that, we get 270 equals 80 plus 95 plus x. We then can minus the 80 over and minus the 95 over. When we do 270 minus 80 minus 95, we find out that the total you got to get on this third test, if you want an average of a 90, is a 95%. And that's how you do an average problem. Okay, so your turn to try an average problem. Here we have Sky, who got a 96%, a 92%, and an 84% on the first 3 tests. She has one last test, and she wants to get the average on her tests to be at least an 87%. What must her last test score be to guarantee that she has that average? Remember, I kept the average formula up there, so go ahead and set this problem up. Give it a try. Pause the video now and give this one a shot. Go ahead and push the play button when you're ready to resume. Okay, so to do the average, basically we know that to do an average we add up the values. So I do 96 plus 92 plus 84 plus that last test score, which we don't know. To find the average, I would divide all those by 4 because there's 4 tests, and that would equal the average, which she wants to get an 87. So to solve this, we're going to multiply both sides by 4 to get rid of the division. When we do that, we get 348 equals 96 plus 92 plus 84 plus x. We then can go ahead and just subtract each of these out of the 348. So I go minus 96, minus 92, minus 84. You can use a calculator if you want. You should have got that she needs at 76% on that last test to make sure that she has an 87% overall on her test averages. So those are the 6 types of problems. We've now done a few examples of each. We did cutting, we did perimeter, we did consecutive numbers. We found price increase, price decrease problems. We then did triangles. And last of all, we found averages. So here's a formula. This is a famous Einstein formula. Energy equals mass times the speed of light squared. C stands for speed of light. Many times when dealing with formulas, we're given a formula and it's solved for a certain variable. Notice that this one is solved for energy. The variable E is by itself. But many times in mathematics, we sometimes want to be able to solve for other variables to know what they would equal in representation of the equation. So what if I were to say, hey, I don't want this solved for E? I mean, I know E equals mc squared. That's all fine and dandy. But what if we didn't want to solve it for E? Instead, we want to solve it for M. So again, we could apply the law of opposites in helping us solve formulas for different variables. I know that E is times c squared. So what's the opposite of times by c squared? Well, you bet. It would just be to divide by c squared. So we could divide both sides by c squared. And that would leave us now with m by itself. And we know that m equals e over c squared. We can do this with any formula. We can solve for different variables in the formula. Let's look at the perimeter formula. Perimeter equals 2 times the length plus 2 times the width. This would be for perimeter of a rectangle. And we've got to solve for perimeter. That's fine and dandy. But what if we needed to use a program? Often in Excel, you have to solve it for a certain variable. What if I wanted to solve for W? Get W by itself. Well, again, we'd use law of opposition. We'd have to get rid of this plus 2L. And to undo plus 2L, we would subtract 2L to both sides. Minus 2L and minus 2L. So I get perimeter minus 2L equals 2W. Now we're almost there. We almost have W by itself, but we have to do one more thing. We have to undo this times by 2. And so to undo times by 2 would be to divide by 2. And so our answer would be perimeter minus 2 times length divided by 2 equals W. Again, we can use the law of opposition to solve formulas for different variables. Okay, so we've written on the board 3 problems here, number 1, 2, and 3. And what we'd like you to do is pause the video, take out your video notebook, and work on solving these 3 equations for the variable that it asked for. So in number 1, you need to solve for x, get x by itself. In number 2, notice that the equation is written for d. We want you to solve it for r, get r by itself. And in number 3, we want you to solve it for y, get y by itself. Pause the video and push play when you're ready to resume. Okay, let's take a look on number 1. You should have done the law of opposites. So the opposite of plus 13 would be minus 13 to both sides. So when you minus 13 to both sides, you get y minus 13, and that would equal x. And notice that now we have x by itself. And so that would simply be our answer, x equals y minus 13. On the next one here, we want to get r by itself. So we need to undo this t. So it's being multiplied. The opposite of multiplication by t would be to divide both sides by t. We could divide both sides by t, and we would end up getting r equals d over t. That would be the answer for that one. On number 3, we want to get y by itself. That's our goal. And so to get y by itself, we're going to need to take care of this 8x. So minus 8x to both sides. And I get 2y equals 10 minus 8x. Okay, looking good here. Now we just need to get rid of this 2. It's being multiplied. So to undo divide by 2, multiply by 2, we would divide by 2 to both sides. And we get y, let's see, 10 divided by 2 is 5, and 8 divided by 2 is 4x. That would be our answer for that one. We just want to look at one more type of problem, and this is one that would involve fractions. So for example, the area of a triangle we know is 1/2 base times height. To eliminate fractions, you can just multiply by the denominator, multiply both sides by the denominator. So notice here we have a 2. If you multiplied both sides by 2, so we times this side by 2, times this side by 2, we get 2a equals b times h. And again, if we're solving for h, we would just divide by b, and our final answer would be 2a over b equals h. So that's the area formula of a triangle solved for the height. Let's look at one more of those examples. What if we had x plus y plus 2z over 5 equals 10? So in a problem like this, again, we'd want to eliminate the fraction. And to eliminate the fraction, you can multiply both sides by the denominator. So to undo the divide by 5, we would multiply both sides by 5. In doing that, we'd be left with x plus y plus 2z equals 10 times 5, which is 50. Again, we're trying to get x by itself, so we would just subtract all that over. We get x equals 50 minus y minus 2z. So we would subtract the y to both sides, subtract the 2z to both sides to get that answer. Okay, let's give you guys 2 more problems to work on here. Okay, so on these problems here, here's number 4 and number 5. On number 4, you need to get p by itself, solve for p. And on number 5, you need to get c by itself to solve for c. Go ahead and pause the video. Give these a try in your video notebook. When you're ready to check your answer, go ahead and push the play button again. Okay, so on this problem here, on this number 4, we would want to get rid of the fraction, get rid of this divide by 2. To undo divide by 2, we use the law of opposites and multiply both sides by 2. That gets us 2q equals, again, these would cancel out because they're opposites, equals p minus q. Again, we're trying to get p by itself, so I need to undo the minus q. The opposite of minus q would be to add q. And that would be our final answer for p. P equals 2q plus little q. Oh, there's a big q and a little q. Okay, on number 5, you have to solve for c. We need to get c by itself, so we got to undo this fraction, undo the divide by 3. The opposite of divide by 3, of course, is multiply by 3. So we get 3a equals a plus b plus c. We then need to get the a plus and the plus a and the plus b over to the other side. So we subtract, and we get 3 big A minus little a minus b equals c. Okay, well that's it for this lesson. Good work. If you need to review anything, feel free to scroll through the video and review the topics that you need to work on. And when you're ready, press the start button at the bottom and you can begin and complete the assignment. Thanks for watching and have a great day.